Hello everyone, myself Sumitra Chaudhary. In this video today we are going to learn about the thin films and their deposition techniques. Thin films can have a great impact on the modern era of technology. Thin films are considered as a backbone for advanced applications in the various fields such as optical devices, environmental applications, telecommunication devices, energy storage devices, and so on. So, what are the thin films? Thin films can be defined as a thin layer of material where the thickness is varied from several nanometers to a few micrometers. So, like all materials, the structure of thin films can be divided into amorphous and polycrystalline structure depending on the preparation conditions as well as the material nature. Thin films comprises of the two parts. Okay, thin films comprises of the two parts, like one is the substrate and other is the target material which is deposited on this substrate. So this is the thin film deposition, where we take the substrate on which we deposit the specific target or the material. Okay, this is the example. This is the example of a transparent conducting thin film which is deposited on a glass substrate. Okay, so preparation techniques for thin film deposition. The properties of thin films are extremely sensitive to the method of preparation. Several techniques have been developed for the deposition of the films of the metals, alloys, ceramic, polymer, and superconductors on a variety of substrate materials. Physical methods covers the deposition techniques which depend on the evaporation or ejection of the material from a source, that is the evaporation or spurting, whereas the chemical methods depend on a specific chemical reaction. Each method has its own merits and demerits, and of course no one technique can be deposit the thin film covering all the desired aspects such as the cost of equipments, deposition conditions, and the nature of the substrate material, etc. Okay, these are the thin films techniques are broadly classified as below. This is the physical method and chemical method. Okay, so for depositing thin films there are specifically there are two methods. One is physical method and other is chemical method. In physical method, this is the physical vapor deposition. In chemical vapor deposition, in chemical methods, this is the chemical vapor deposition technique. So evaporation in physical vapor deposition, evaporation includes the laser, E-beam, thermal evaporation, and ion plating. Sputtering involves the DC, RF, like DC, that is direct current. This is a radio frequency sputtering, and magnetron sputtering and reactive sputtering. Spray pyrolysis includes plasma and flame. In chemical vapor deposition includes MOCVD, that is molecular orbital chemical vapor deposition, thermal chemical vapor deposition, PECVD, that is plasma enhanced chemical vapor deposition. Plating involves the electroplating and electrolysis plating and sol gel. Okay, now the selection of deposition process. Choice and selection of deposition process plays a vital role in the formation of good quality thin films, and while selecting a particular technique, it should be tested satisfactorily for the following aspects. Okay, this should be the cost effectiveness. It should be able to deposit the desired material. A film microstructure and deposition rate should be controlled. Stoichiometry should be maintained as that of the starting material. Operation at reduced temperature. This would be adhesive at reduced temperatures. There should be the abundance of deposition materials. Scaling up of the process. Masking of the substrates. Control on the film substrate interface and the defects created in the film. So these are the selection of the deposition processes. Here in this video we are going to discuss about the sputtering deposition process. So the sputtering deposition involves the collisions of energetic ions with a target surface. and the process usually leads to the ejection of the target atoms. This is the diagram for the process of the ejection and the deposition process in this sputtering. So, and this is the schematic diagram for the sputtering deposition process, where this is the power supply, this is the gas inlet here, this is the vacuum pump here, from which we vacuum this chamber. This here, this is the target which we are going to deposit, and this is the substrate, that may be the silicon, glass, PET, etc. So in the sputtering deposition process, sputtering technique is most commonly used for depositing metals and oxide films by controlling the crystalline structure and the surface roughness. The simple form of sputtering consists of an evacuated chamber containing metallic anode and cathode. So here, basically in this chamber, here the gas, this is the gas inlet where we use the neutral gas. Here basically here we use the argon gas, which is ionized by this internal power. This external power supply, producing a glow discharge or plasma. This interacts with the target atoms, and atoms are ejected from this target surface and are deposited on this substrate as a thin film. So this is the process of the sputtering deposition process, where ions are accelerated into the target. Some of the surface atoms are sputtered off from the target. These sputtered atoms flow across the chamber to where these are deposited. Okay, so the sputtering process is characterized by the sputter yield, that is denoted by S, which is typically in the range of 0.01 and 4, and increases with the mass of metals and energy of the sputtering gas. The sputter yield depends on specifically the energy of the incident ions, the masses of the ions and the target atoms, the binding energy of the atoms in the solid film, and the incident angle of the ions. So now the elements, alloys and compounds can be sputtered and deposited. The sputting target provides a stable, long-lived vaporization source. The source and substrate can be spaced close together. The sputter deposition chamber can have a small volume. There are 4 types of sputtering deposition process, that is DC sputtering, direct sputtering, radio RF sputtering, that is radio frequency sputtering, magnetron sputtering, and reactive sputtering. So in next video we will discuss about all these sputtering deposition